Hello, and oh wow, my mic always with sound, always starting with the sound. So, morning, Adam. Like my new background there, the little gopher there. That's from Ashley. She did that. I wanted a metal one. She hooked me up. It's awesome. What am I drinking today? Louder roasting. Good stuff. Oh, it's just me and you so far. So today I'm going to cover composite types, which I think is pretty fun because Go's JSON support is, well, it's not as wonderful as and easy as the native nature of JSON support in JavaScript and its dynamic capabilities, but it's pretty nice nonetheless. I guess one could argue even that it is, you're doing it in parallel. Oh man, setting up the streams, it's just like it's a massive workload up front. Then you finally get to do it and coordinate it. So speaking of that, since just me and you, and for people watching, right, that's a good tip. Don't do this without caffeine. Make sure you have some remote idea of what the heck you want to do. That goes without saying. For instance, like my guiding path, even though I'm even though I'm basically doing this off the cuff, I'm using this book by Donovan and Kernighan as kind of the guidepost to make sure I hit all the bases as I go through the material. So that's good. That's a big tip on doing streams. Have content, have a path in which you want to go. Speaking of that, one of the people who we may raid post all the content today, but Code Enjoy is someone who I was following yesterday, and he's been going through all of the steps of basically making streaming a full-time gig for himself, which is pretty cool. So he was going through like GitHub, GitLab, Jira, all these different issue management suites and figuring out what he wanted to use for his project on the stream. And by doing so, he'd already, gotten together a whole crew of people to watch him do that. And we were all kind of providing suggestions and things like that. And he was, a lot more than just what I mentioned too. He had like 30 different lists, but definitely somebody worth going to follow and check out what he's working on. He's putting a lot of effort into it. He's got all types of plans. Seems like a very organized fella too. And he's just outside of Stockholm, so a little offset with the time, but still really cool. Yeah, no matter how good you know it, when you get on stream and you're trying to talk about it, it's a different story, right? Kind of like if you try to go to the next level of presenting and you don't use a slide deck, kind of like you've done a couple times. Super awesome, but holy shit, is it a completely different level of presenting. Like when it's pulled off, amazing. But trying to get to the point where you can pull it off good is just ridiculously difficult at first. I've gotten to the point where I can talk without a slide deck. Doesn't mean I'm going to give a good presentation, but I can talk about stuff all day long without a slide deck. All right, getting into all this jazz today. Welcome everybody that has joined. We'll probably be seeing some new faces. That's a colloquial statement that just doesn't work in this case. But let's get into some code. We're going to be talking about a couple things today. Let's get a little note page up here too. Should I use? I'll use get it again for this. No, that's silly. Let's use code. We'll open two browsers. Now let me get to the desktop first. Let's see, where am I? There, desktop, clear, code. Bop, doom. There we go. Yeah, so here I'm gonna just write some of my standard notes for what we're doing today. Today's coding learning Go episode 4 markdown. Boom. We're going to be going over composite types. First thing we're going to cover is arrays and their what I consider kind of weird flaky nature in Go. Once you figure them out, they'll make sense, but up front it's kind of like, why don't they work like ones in other languages? Which is a common feeling in Go, in my opinion, is, oh, look, there's this thing like it is in other languages. Oh, dear God, it works completely different. I don't know why this makes any sense. But, you know, again, familiarity brings capability in the language. So, and then after arrays, we're going to tackle some stuff around slices. Let's see here, slices. And then we're going to talk about append. And this is important because append is one of those things where there's a whole lot going on with append. We need to make sure that you know, that we're not misusing it, because it will destroy your performance when processing things if not used correctly. Because there's a lot of movement of bytes and writes and rewrites of stuff moving in and out and all that. We'll talk about that though. That's here. And then there's in place slices. And then we're going to talk about maps a bit, which is kind of self-explanatory. If you know how maps work in software, this is very, very, very similar. And then let's see here, we need to hit on structs and struct literals. Let's see here, structs, struct literals. And then let's see here, one of the, oh yeah, and then we're gonna get into JSON. That's one of my fun places. I like the JSON. I like the JSON, but I don't like the JSON, if that makes any sense. Just like I like XML, but I also don't like XML. Figuring out a format to use to get data moved back and forth can be a tumultuous experience, to say the least. It can end up being weeks, months of pains. The other thing that I'm going to do today, which will actually be after this session on Go, and you'll like this one, Adam. So I'm going to live stream nuking Windows 10 completely and reloading this XPS 15 that I'm actually streaming on. I got the webcams and everything, got multiple webcams, so we get multiple angles of the action. But I'm going to reload it completely and probably just put Ubuntu on it up front, because I know Dale has shown Ubuntu support specifically across the board on a lot of devices that I have for this, and the devices, or the hardware in the laptop. And I will be streaming that via, here's a funny part, I'm going to be using a Mac to stream it via the webcams, but I'm going to be reloading this machine. So that's going to be kind of funny. But I also have another machine that I'm going to set up and show how to set up the initial boot USB stick, which I have a little bitty USB stick there that I'm going to use. Pretty cool. And I'm going to set that up originally with my XPS 13 to reload this XPS 15. So I'm going to do that sometime. It'll probably end up being around 1 p.m. PST, 1:30 p.m. PST. It's open to a change in schedule because this session takes priority. I need to get this stuff covered and make sure we're ready for next Saturday when we get into functions, which is going to be super badass. Functions are like the heart of Go, really, as far as core functionality and everything. Yeah, so I hope to record the reloading of this machine and show all the pieces and show how easy it is. It may only be like a 30-minute stream, honestly, because it's quick to reload. But I have no idea what type of driver things may come up. I have no idea what will be or won't be supported post facto, what I'll have to do, any types of hacks. So I'm going to cover all the bases. It might end up being a 2 or 3 hour stream, But like I said, it might be a 30-minute stream because the core Linux OS does reload on one of these machines like this. It's super, super fast. When I reloaded my XPS 13, it only took about 12 minutes to reload the whole OS and basically be up and running with Visual Studio Code. It was ridiculous. Like ever since I started using Linux, I just don't know why I wasted so many bloody years spending hours and days getting clean reloads on Windows just to use Visual Studio. It's just a nightmare. I can't even remember, or I can't even imagine how many hours and days and months of cycle time enterprises have used to fight and get that working. But anyway, the enterprises, knowing them, they'd probably do the same thing if they were using whatever OS. But from a personal perspective, there's more overhead there, period. But I digress. Let's get into composite types. So I'm gonna, oh, that's another project I'm working on. Let's close that. That's a lot of busy stuff. We're gonna go into Golang and start a new project again. And we'll just call it, let's go by our naming convention that I started last couple of sessions. So if I go to GitHub, good sample, that wasn't it. Where is it? There we go, Learning Go to episode 2, episode 3, and we are on episode 4, of course. So let's go with that. Learning Go episode 2. Okay. 4. Learning Go episode. Yep. Just making sure I spell it right, otherwise I'll just mess myself up all day long. All right, there we go. Let's get a main file in there. All right, and just to have some basic, hello, let's talk composite types. And then we'll go ahead and add the build configuration for this. Just go ahead and get busy work out of the way. No, that's a lousy name. Run, Nyan Cat, run. There we go. That looks better. All right, hello, let's talk composite types. Cool. So, one little tweak here. Oh, I just realized I don't have, oh, there it is. So, the first things first, arrays. Let's look at this. So an array, specific definition is an array is a fixed length sequence of 0 or more elements of a particular type. Because of their fixed length, arrays are rarely used directly in Go. Slices, which can grow and shrink, are much more versatile, but to understand slices, we must understand arrays first. Very, very good point. I read that from the book that I suggest everyone get for this particular course of material. So this is one of the things where Go totally throws me for a curve, right? So there's no way to really grow and shrink arrays per se. An individual array can be set up. Like let's set one up real quick. Let's just say basket of stuff. We'll use the short declaration of is equal to, and we'll say, I don't know what we want. Let's do 3 string like that, and then we'll go ahead and assign it these values, right? So first string, second, and this string, right? And then if we did, another common one you see all the time is let's say we have var z values. Whoops. We'll do 3. Let's do a different range here. Let's just do 2. And then int. All right. There we go. So this is 2 different ways to declare an array. This is the first one here, which has this many values. Oh, we should do well, yeah, let's go with that. 4th, oops, because 0. Now, like in JavaScript and things like that, you would notice, what did you say? Let's hear, you can use a shortcut suggestion, add in. Shortcuts used. Oh, yeah. So here, if this was, let's say C# or Java, and you're setting up an array, and you say it's 3, you'd be 0 base, so it'd be 0, 1, 2, 3. So you'd have 4 values. But the Golang IDE, knowing what you just did, already says, hey, you just declared this array to have 3, specifically just 3, 1, 2, 3 values. Now, that would make it the index out of bounds if you added a 4th element and cause an error, right? And thus, an error in Go creates a panic, causes the application to crash, or in this case, not even to build, right? So if I added, actually look at the build real quick, blah, and then I try to build, I just get this. Boom, yeah, array index out of bounds, right? One of the beautiful things of a strongly typed language. You can't do goofy stuff like that. So this one, just have the 3. But now if I want to print it out, let's say for value range basket stuff. There we go. So let's say format.print. There we go. Do that. And then value, oops, value of D. Wait, but we want to put the number in too. So let's do D, and then it's a string, not a D here. So this, and then I'll say I believe, and then value. So if we step through like this, we should get, oh, let's see values. Oh, right, it's not declared. Let's put this right down here. Format.print F. Actually, let's do print line. You can see what happens when you just do a straight out print here. Z. Can you alt enter to mage the 3, 2, 4? Oh, that's a good question. I don't know. I've noticed some things that I'm used to in ReSharper and like JetBrains Writer aren't quite up to par yet with Golang, but some of it's just because C# is such a fleshed out language, right? Same thing with IntelliJ and Java. Like a lot of the refactorings are more elaborate because it's just a simple fact that the language has been around longer, or the IDEs have been around longer for the language, so they've built in more capability around that. They're still kind of tweaking on some of the Golang stuff, but I've noticed in the last few releases they've added a number of awesome refactorings and alt-enter capability. So, all right, that gives us all the stuff printed out. Cat's gonna run. There we go. So, value 0, the first string. Value 1, oh, we should have, this is not very nice. Let me clean that up. Boop. There you go, add that, and I'll run it again, just so we can look at it in a nicer format. There we go. So Z values, which is empty, just prints out the array in brackets of 0, 0. Because when you create an array like that, it's going to initiate values for those ints, which will be 0, 0. Because it's just going to assign the value 0 to it. But we'll talk about that a little bit more in a minute. If you remember from one of the past sessions, if you use like the new keyword to create a new integer or a new string, which would be an empty string, but then you do a comparison, it's comparison on what the underlying byte array value is, which is different. So like empty string of an object that's not the same object as the other object that has an empty string, they're not going to equate, right? Because they're different objects. They just happen to have the same value. Same thing with int. Even if it's 0, 0, you know, it's not going to balance out when you use the new keyword. But we'll look at this and do a comparison on it in just a minute to see what happens when we're just declaring. We're not using new, we're just declaring an array that happens to have two int values that then have been defaulted out to 0. On our strings, however, we have value for index array 0, 1, and 2. You'll notice the array is still 0 based, even though here we say we want 3 values, but that just means it's going to be 0, 1, 2, right? So there's no third index, even though there's 3 values. Indexes for the array start at 0, but when you declare it, you're telling it how many values you want to be able to have, or you want in, not be able to have, but what you want in the array. So that's an important differentiation in Go versus some of the other languages that say, if you say the array is going to be 3 long, that's really 4 values because you start at 0. And arrays almost always in almost every language start at 0. Important differentiation with other things and how Go works, etc. So we have this array with 3 string values, it prints out, and then we have the z values. So let's do a comparison here and say, how should we do this? Let's say if z zero equals z values 1, let's do this. Else, we want this to happen. Okay, so if both of the values are equal to each other, then we can say format.print the values are the same. This doesn't instantiate like the new keyword, right? But if this happens, format print line, the way Go appears to instantiate unset variable values such as in this array is like the new keyword instantiation. It's almost like I'm writing documentation in the code. That's what it is. It's example code to show how it works, right? The values are the same, thus it's not doing it the same way as new, right? It's actually setting a default value and it's letting the comparison be the same there. All right. So that is arrays. Okay. Let's see here. Let's look at some of the weird stuff that you can do. So if you want to say format print, we'll do line again, and then z values. Oh, actually, let's do this first. Let's do something with z values so they're different. Z values, this one equals 1 plus 52 times 3, whatever, just to do a calculation. Z values, this one equals, let's just go with 9. Now if we do format print line and say z values, now in this, let's say we say z values, we'll do, well, I think I just overdid that one there a little bit. Z values, length of z values. Okay, so that's going to get the number of items in the particular array. Again, kind of a weird thing. I've never really understand why length, I guess it kind of makes sense, but it's not like count or number of or something that's very specific to the point about how many items are in the array. But basically that's what len or length is looking for in the particular thing that it's passed. That function, that built-in core Go function, will get the number of items in the array in this particular case. So I'm going to say that and then -1. So that should take the total, which would be 2, and then take away 1. So now the question is if it takes away 2, does that mean the length is 2 minus 1, so you get 1, so it'd be the index value of 1, so it'd be the last one, or would it go to 0? Well, in this case, since we've written that out, I'll run it and just show you. It's going to get 9, which is the last value. So it does. It takes 2, right? And to get the last value of an array, you would have to do this calculation where you take array, then you're looking for the particular index, the last item of the array, and you could say length of the array -1, because you couldn't say length of the array and put 2 in because it'd be out of bounds, right? All right, let's hear what's some of the other crazy stuff we can do. We did that, looked at that. Yes. Let's talk money. Money's cool. So let's create an actual type, okay? And we'll call it currency. And it'll be of type int, okay? Now, of course, you might be thinking, oh no, currency is floats, right? It's a float value, but we're gonna be talking specifically about a currency type, like the dollar, like the yen, like the peso, those types of things. So then we have constant, and we're gonna set this up to do US dollar. We'll say currency, that's the type, and we'll start at iota. Then we're gonna do the euro, the British pound, or Great Britain pound, and let's see, what is the euro, not euro, I mean, let's look up some real quick. Yen, money code. Actually, let's see, money currency codes. Or I guess it's symbols, whatever. JPY, that's what it is. So we're gonna put in JPY. And then what else we got? Euro, Kwanzaa, AOA. Yeah, let's put in AOA, why not, right? AOA, I just want to add like 3 or 4 more. So we'll do AOA, then we'll do, anybody got a choice one? Maybe, oh, Norwegian krona, NOK, AOA, whoops. AOA, NOK, Brazil, nah, Bosnia, convertible mark. That's an interesting one. I didn't know that. BAM, I like their code. That's good. BAM, bam, bam. Let's do the Danish kroner, just to be confusing here. Oh, and we'll do the, the Swedish krona too. They do that, right? LM and O. I always forget how many countries there are until I actually look at a list of countries. There is a lot of countries. Sweden, SEK. Okay. So there we go. SEK, DKK. All right, so now we have constants to represent each one of those. And then we'll do symbol is equal to. Now here's another little thing which says all this that's about to be assigned, right? So you don't have to count them basically. It's gonna be a string, and then we're gonna go with USD, which will be the $sign. And I need to make sure, does this chart have the, I needed to see the, it's your currency code, currency codes, and symbol. Is it going to show it? Yeah, this is world currency codes. I want to be able to copy it out of the page instead of having to go look for it in it. Yeah. This is it. Perfect. So let's see, your first one, AOA, is going to be a weird one. Oh, and I can't even find it. Sorry, AOA. We're going to actually take you out of there. So there's USD, and then Euro. It's going to be whatever the Euro one is. And then let's do British Pound. Go ahead and type these in here, and then we can get them all found and stuff. JPY. Then OK. SEK. DKK. Oops. DKK. And there we go. Okay. So now, see the Jersey pound. Oh, that's funny. So let's take the yen here. Oh wait, is this? Gonna make sure that's the right character thing. Graphic image. Yeah, I don't want the graphic image. Arial. Oh yeah, I definitely want that then. So we'll take the yen here. Right. I don't want it over there. Yeah. So copy that and put it in there. And then we'll take the euro. That's down again, 114 only. Still better than US dollar. Euro member countries. Whoops. Euro member countries. Yep. England's doing all that Brexit stuff, and they've never joined the currency. But GBP. And of course, I guess that's like Sweden part of the euro. I think it's Norway and Denmark and maybe are part of the EU, but Sweden's not. Something like that. Something weird like that with the Scandinavian countries. But they all still use their own currency, which is krona. But they're all different bloody krona, which is super frustrating when you go there and you're trying to remember which krona is which one and what changes to what. So they use KR. And then and they use KR. Oh, let's make it more confusing. Their codes are different. And then Denmark. And there's KR. Of course they would all be the same. So that's super not useful if you're trying to do this stuff. You know what? I'm taking you guys out. Sorry, you don't get a spot right now. Or no, I guess I can, because then I'll add Canada. Let's add Canada. Well, it didn't do the thing, but of course it's the dollar too, just like the U.S. It's almost like it's the exact same thing. What did I do here? I fat fingered something. Am I missing a comma? Worth pennies. Yeah, exactly. Let's do this. Boom, boom. And we'll just change this. Canada. Oh, der. It's because I didn't add it to the constant. I need to have it up here. Okay, there we go. So now I've assigned the symbols. And now, with that declared, one of the things that you can do is format.println, and then say you want to do euro, right? You can even say symbol euro, like that. So now, what's that going to give us? It's a good question, right? Let's do 2 of them, just for good measure. Let's do the yen, Japanese, then the symbol. Oops. If we run that, what we will get is pretty straightforward stuff. See, it shows the symbol, so it knows how to look up the symbol based on the code. So now in code, instead of like putting this in every single time or whatever, you can put in a more readable statement. Say, I want the symbol of the euro, or I want just the euro, and then it puts in what numerical value it is within the constant here. So it's like an enumeration. All right, so that's all fine and dandy. So let's declare another array. It's a bit of a crazy slant to it here. So if I do this, it means I'm not saying how many are in the array just yet, but then over here in the declaration, I'll say 99 to -1, which will mean give me 100 elements. Okay, so now I can assign R, let's say 36 to a value. Oops, doing an int here. So 425, and then R42. Let's make that 42. And there we go. So if we print that out, R42, whoops, we'll actually get 42, right? Yep, there we go. And the same thing if I put R36 right in front of that, concatenate it together with a little space, and boom. Oh, I broke it. Mismatch types int and string. So there's another Go thing that you need to watch out for. So it's not going to just turn this into a string, this int value in the array, when I'm trying to attach it to this thing. But let's say if I just do this, it'll just add them together and print it, right? So 42 plus 425 is 467. Yep, that's what we got. So if we want to change those to a string, though, we'd have to say format.println string convert. Of course, I covered this in other ones. And then what is it? Int to string or alphabet, whatever it is. Yeah, so this is string. Yeah. So then we'll put R36 in there. Why do I keep typing 2 for R? Some weird dyslexia I got going on today. Multiple, oh yeah. So I'm gonna hit Alt-Enter, like Adam pointed out here. And then that gives me a bunch of options of what to do. Fixed all unresolved, suppress. None of these are what I actually want to do. I want to introduce local variable maybe. Yeah, I want to import. Yeah, I just want to import. That's the core lib. That's what I wanted. Oh, and did I not? I don't think I cased this right. Yeah, there we go. Capital. Because of, again, visibility when on a function or on a package object thing, it has to be uppercase to be exposed outside of the package, right? So lowercase, basically internal pseudo private functions. uppercase is publicly accessible functions on packages. And that's followed very strictly on the core lib. All right, so there's a bunch of other ways to do arrays and get values out of arrays. But what happens when you want to do not that? You want to add to it, or you want to do some other things. Well, let's talk a little bit about slices and what slices give us the ability to do in Go. Because slices gets us a little bit more into the space where it's dealing with arrays a little bit more like you would in, say, JavaScript or C# or Java or whatever, where you're actually manipulating and adding to or taking away values in an array. Excuse me. All that morning coffee. So here, let's see, what should we do? Let's do, I'm going to actually take an example from the book. Say months is equal to their string, not strings, there we go. And then we're going to enumerate the months, January, February, March, and April. So we're just going to go with that for now. And then of course let's stick the last one in, right? 12 December. And I did not put my ellipses appropriately there. There we go. All right, so that's our months. Now, in this particular case, it's going to be an array of 5. We can go through it like this. So if you're looking at this 4, the way I just did this is I said ignore the index point. I just want to print out the month. So the underscore is ignoring the index because I'm not going to use it. I'm not going to print out like 1, 2, 3, 4, etc. But I do want to print out the value that's at that point in the index. So I'll say format.print, oops, F, there we go. And then let's say the month, and then just print it out. Like that. So that's another way, that's a way to declare an array / slice. And there you go. You can see the month at the bottom there. I should do this, clean it up a little bit. Boom. Right? Oh, because I actually put 12 here, I explained that incorrectly. There's 5 actual values in the array, as you can see. And there's 12 in there though, because that's the number at that position in the array. So if I put 12 here, there's actually going to be 12 values in the array. So there's December, and there's January, February, March. Now, the kicker is, yeah, it looks like, yeah, so you still have an index of 0 array value, right? Which is going to be 0 because we're not putting anything there. We're just going 1 through 12. But anyway, so that gives you an idea of how to declare something like that, which is getting us a little bit closer into slices. So a slice represents a variable length, sequence of values, right? So it is a variable length sequence whose elements have the same type. A slice type is written by bracket T, where T is type. And it looks like an array, but it's an array without a size, okay? Now, in this particular case, what I did was I created a slice, but then I said, here's the values in it. So it's already like pre-initialized the, yeah, exactly, 13 months. I pre-initialized the slice. And emphasis again, slice is basically an array, but it's allocated so that we're going to dynamically manipulate it. It's going to be mutable versus an array, which is just declared as an array and given its initial values, and that's it, is done so in a way that is immutable or not changeable. That's the values, however, and this is where Go is definitely not a functional language, the values can be changed, but the array size is basically set. To do anything else, a new array has to be declared, or you have to append something to it, etc., which is where we get into slices and then the append core lib functionality. So, I wish I had a graphic for this, but basically, when we, like with the months, we have it inserted into the array, or they're put into the array when they're declared. And when you want to say, let's say we invented some new months, like Guva month and Juba month or something like that, and you wanted to say there's 14, so you'd have to do append equals the current array of months, comma, the new slice that you wanted to slice into it and add to it. That's the way I always think of it. It's like you're actually slicing into an array to add to it. So let's take a gander at that. So, oh, it's here. We'll say, actually, let's say months equals months, oops, append, because there's a slice, months, right? And then the new element is going to be, cannot use months type. Ah, that's because it's set at this point. Let's do another one. Let's do var. We'll do another one from the book here. Again, great book to get. Rune for this r equals this. So it's a slice because there's no declaration in the brackets there. So we're going to say range, hello, and then I'm not putting the Chinese characters from the example in, but feel free to. Actually, you know what? Let's go do something like that, just to show you how fun the Unicode stuff can be. Chinese characters. Yeah, there we go. Let's just go there. Oh, there's some basic ones. Let's go look at the basic ones actually. So let's do great. Let's do go sing. So, oh, of course, heaven forbid the thing is available in the character. Chinese Unicode for, or Chinese character for go. Oh, there we go. Perfect. Is that right though? That doesn't even look like what I just looked at. Simplified. Do traditional? Yeah, let's do traditional. We'll throw in an exclamation point. Actually, just do that one. There we go. And then we're going to do runes equal append runes r. All right. So up here, there's nothing in this runes array, but by the end, we will have this item in it, right? And then let's say format.print. Actually, let's just do line, then you get to see the whole thing. Runes, there we go. Oh, look at there, that's that's the number. So it doesn't show the position. Let's do this though. Let's go and say Didn't want to delete the whole line. Runes. We'll do %q/newline, then runes. So first we should just get, what did I type wrong there? It should append it, and then it should print it out. That's a weird one. Possible formatting directive. What do I need to do? Q? No. Damn it. Why is it? That should be the formatter verb for it. Language. There we go. Just doubling down here. It'll do it, right? No, it won't. Oh, they're used the wrong function again. Of course, it doesn't know what to do with a formatter if I'm telling it to not use the formatter. There we go. So it should just print out the string just as is right below. Yeah, there we go. Boom. So let's do this. And what do we get? Yeah, there we go. So that's the array now. Language equals go, or is go, whatever. All right, onward. So that's how you append to a slice, which is basically, you're dealing with an actual array where you can do various things with it then, okay? Let's take a look at something that's going to explain a little bit more of what's happening though. Let's say var x, y, we're going to make it int. Notice that's a slice. So for I is equal to 0, step on through that, and then let's go 10 and I plus plus. So basic enumerated for loop. And we'll say y equals append int. No, why is it? I don't think it has the core lib in there. Anyway, we'll do that and it'll find it in a minute. So that's why. It's because that's the example. We'll go back and do this in a second. Let's see if we get refactoring here. This would be cool if they did. Change signature, extract, method. There we go. So there's another awesome, super, super awesome capability of, oh, that is weird though. So it extracted a method and it stuck it inside, but it put the signature here. So that's cool. So I wanted an int and then an int. So I is just an int, right? And the x was an int array. So it knew what to put here and then it stuck this in the middle. But really, I wanted this here and then, yep, okay, cool. So it did the rename and everything for me. All right, so we got that. Now let's flesh this out. We'll say var z is int. Oh, we want to return an int array, or int slice array. I'm just going to call it that. We'll go with z length is equal to length z plus 1. Then if z length is less than or equal to cap of x, blah, 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 do this stuff. And what did I, always fat fingered something. Else, do all this other stuff. I really like that refactoring. I just want to make a bunch of functions and not have their bodies declared and then have it build them for me. Z length, there we go. Then here we want to do z cap is equal to z length. then if z cap is less than 2 times length of x, z cap equals 2 times length of x. All right. Don't worry, this all makes sense in just a second. And then z is going to make. Remember, make is another way to basically set up some values, right? Int, or declare some values, I guess you could say. Z cap. So that makes those into z, and then copy z to x. That's a built-in function, the copy there. So it copies value to value, or object to object. And I'm going to come down here and z length x equals y, and then I'm going to return z. Okay. Now notice z is this, but that ain't really going to work because I want an array. Oh wait, what the hell did it type? Y, there we go, and then return z, right? Yeah, there we go. Why is y dead though? Why? Oh, I feel like I've missed something now. Copy zx, z cap, equals z length x equals y. And we'll come back to that in just a second. So this though, we want to say now format dot print f, and then let's say d to get that value there. Cap is d dash v slash n. That should give us that, and then I cap y and y. Right? This code. So let me read through it again here. So I got a var z is an array, and then z length is equal to length. Actually, I needed length x plus 1. Yeah, that's what I need there. And then if z length is less than or equal to cap x, then do z x, get the length part of the slice of the x array right here, right? And then here we got z cap is equal to z length. So we have a new value for z cap now. And it'll say if z cap is, oh, what did that, oh, whoops. Sorry, look at my phone here. There we go. Somebody was asking a question. Oh no, it looked like somebody was asking a question. Just wanted to check. So if z cap is less than 2 times length of x, so basically how many values, the size of the array of x, or size of the slice array of x, then it should be z cap equals 2 times length of x. Okay, that's right. And then z equals make, and we're doing an int array, then z length and z cap in there. So then we copy z x, and then z equals length x equals y, return z. Okay, that's how the example is outlined. So we'll see if that works here in just a second. Oh, and yeah, I got the function there. Make sure the formatting of the code's right. So we got our main function up here with all these examples, and then we have the append int here, which I call here in the for loop, which should then print us out all of this jazz. X equals Y. And it should loop through again and act on that. So it should incrementally add to and count out the array, okay, and talk about the cap value. So now here's the question. Looking at that, what is this going to look like, right? Changing the capacity, which is what this for loop is doing. It's changing the capacity of the int array to grow it, okay? The slice array, sorry, I keep missing that. The int slice arrays here. So let's run it and see what we get. Import and not use math. Why is it still there? Well, let's get rid of it. So another helpful function of Golang. I could just delete this manually, but I'm going to hit Alt-Enter, and it's going to say import for side effects. So if I did that, it would do this, right? So the underscore in front of that, just like in functions, instead of returning a value and then expecting one to act on it, right? It would just say, okay, we're going to ignore this particular return value. So if a package needs imported for some side effect to occur, something that if you're a functional programmer, you go, whoa, why would I want to do that? But in Go, sometimes you want the ecosystem of a particular package, the functionality of it that's happening in the background or something to be available. And that makes it available to this library, okay? Doesn't mean, but it basically means you're not making a call directly to the math package. So that's one way to do that, but I don't have any of the ecosystem of the math package that I want to be running in this. So when I hit Alt-Enter this time, instead of importing for side effects, I'm going to say optimize imports, okay? And there's various options here. It says fix all unused import problems in file, blah, blah, blah. And basically what I am going to do is just hit Enter. Come on. There we go. And what that does is if you just hit Enter on it, it's going to, by default, take out any of the imports that aren't actually used in the code. It's just going to immediately clean it up. Similarly to looking through the logic of what Go format does and the build engine does in finding that these things aren't used, and it just takes them out so that it doesn't have to worry about building those pieces, which in turn is one of the things that makes Go build so fast. All right, so now I'm not using math anymore, undefined Y. I'm confused by this damn example in the book. So we're just going to take this out right now. And we're going to go crazy here. What do we get? There we go. So even though it's sticking zeros in there, I'm supposed to be getting a count, which was, I don't know, I've turned myself around by Z length equals Y. Y equals, Y isn't assigned. But anyway, okay. So the idea that this shows is that the array is growing and the cap end grows, but you have to create a new array slice every single time to grow it. And that's kind of what this example is showing, right? Because each new array here that's created is a new array, and thus it's grown by that much. Alrighty. And depending on how big the array already is and how big you want the array to be, it bumps out X amount, and it could overgrow what you actually need. But then that can get tricky. So you want to kind of control how you grow these slices. Definitely worth reading up very specifically when you do a lot of array manipulations to see how append works, to see how the arrays work, and how the slice arrays work. But for now, we, in this session, are going to move on into, let's see here, some in place ones. We're going to actually jump into maps. So maps are fun. Maps are basically, it's, okay, so a hash table is a pretty versatile data structure. I don't know if you know what a hash table is. It's basically an unordered collection of key value pairs. Okay, so you have a key and then the value that's associated with the key, and you have a whole list of those inside of this hash table. That's what a hash table is, okay? And the value associated with the key can be retrieved, updated, removed based on that key. Okay, and in like a distributed database, this is like a key fundamental premise. No intent to make that a pun of the word key, because that was overuse of it, but it's one of the main points of a distributed database. The way that they store things on a consistent hash ring is all the things stay consistent among all the nodes and can be retrieved by that key and always be retrieved by that key. Now, you can kind of also think of the key from relational database land like that of the primary key. The primary key is designated in a table to be able to retrieve a bunch of values from the table. But in this case, this key value is just a key and just the value. That's the hash table. So in Go, a map is a reference to a hash table. And it's written based as map, key, and then V. Okay, let's actually write code instead of me just like drawing in the air with my fingers. We're gonna actually go down here, terminal, get status, get init, get, let's create our ignore file. And then here, just gonna do some of the basic stuff that we always do, .ida. For Mac users that pull this down, we'll go ahead and get rid of your .ds store. And then I'm gonna use the little quick cheat. I always just go out and look at one of my existing repos of goodies. So we're gonna look at yesterday's session, or sorry, last Saturday's session, and we'll grab that get ignore file. I'll make this episode 4 in case we build the binary. And get add.get ignore. Whoops. Added get ignore. Boom. And then we're going to add all the other bits. Get status. All right. Get commit. First commit master. Get -v. Whoops. Get remote -v. We don't have those up there. Let's create our Learning Go episode 4. I don't know, sometimes I don't really like GitHub's interface. Stuff seems to be not in the right places all the time. Learning Go episode 4. Right? Learning Go episode 4. Yep. Episode 4, code for Learning Go. Create repository. And then we're basically gonna, let's hear, do this. Clear, get status, we're all good. So then we can push to the origin master -u, make sure that we map to it. So our changes will actually continue in tree. And oh, do I not have, oh, whoops. Derp, I have to add the repo first. So let's do get remote. There we go. And that'll add that. Oh, get out of here. What did I just, oh, I added 2 gets. There we go. Now we got it in there. Git remote -v. There's our remote repository. So now we want to do this command. And that'll push it up there and map us to the master branch. Then once that's done, let's say git branch. Let's see, let's do the next one, maps. And then I'm going to check out that. What's the command for doing git to create a branch and then automatically check it out and move into that? So like getting, that's your git check out master is basically what? Let's hear it. So it's, I know it's checkout, but like if I want to create the branch, like git branch blah, but I want it to check out too. And there's like a switch or something, right? That I can say, create this, but I also want to immediately check out and move into it. Yeah, that's it. So let's say git checkout branch. And so that's gonna -b. Yeah, okay, cool. -b learning maps. Yeah? Oh, I can't spell checkout, obviously. Learning. Thank you, Sultanato. Right, yeah. My chat is on, you're gonna hate this, Adam, but it's on an iPhone. Oh yeah, yeah. Well, we don't need to get that complicated into it yet. So this is a helpful little bit though. Create the branch and you're moved into it. So now if I do a git status, you can see, boom, on branch learning maps, nothing to omit, working tree clean. All right, that's exactly where we want to be now. And now I can do stuff like, let's nuke this whole bit of code, and we're gonna write some fresh, clean, new code. So that example, of course, will be in the repo under master branch, but this is gonna be under this one. So a little while ago, you saw where the import got out of sync. Like I added some stuff, it thought I needed math, probably did. That's probably why that Y thing was out of sync and there was a little bit of missing code or whatever. But anyway, it had math, stuck it up in the imports, but then the IDE kind of tripped out and said, I don't know what to do with this, squiggly line, you have an import you don't need. And I went up and did Alt-Enter and got rid of it, okay? So the IDE will eventually sync and figure that out and then ask you what to do about it. But most of the time, like I just deleted all that code, and note, it removed all the imports because it knows now, it's like there's no reason for it to be here. Doesn't need the imports. There's no functions mapping to anything. There's no confusion. So the IDE just cleans it up. But then also, you've maybe noticed as we've gone through these sessions, I've not really written barely any actual imports because as I write code, Golang will just put the import up there as soon as it determines which one it is. Oh, sweet, at PDX node or node PDX. Yeah, we made that confusing on purpose, but it doesn't matter. It's all good node, all good PDX. Cool. Glad to see you on the stream then. Um, so yeah, let's see here. At 1 hour 17 minutes into this thing, I can tell you there's one good conference coming up that I know about because we're doing ML for All again. And that's going to be April 28th, 29th, and 30th. Really, really looking forward to it. About to get some word out as soon as we actually get the page up that, like says, there's a conference. It's going to be on these dates. Here's where you can buy a ticket. We're going to be knocking that out this weekend. Lena is working on it with me, and Troy is, of course, spearheading boots on the ground in Portland to get the space and all that kind of good jazz. And we're moving forward on it. So that's going to be happening in April. Super stoked. And I know there's some other good stuff, kind of some of the other standard stuff that Like Monitorama is pretty awesome. I've never been, but I've always hung out with people whenever they're there attending the conference, which is super badass. Um, I suspect that you could present on, or perform. I guess you could perform information systems. And yeah, we'll be opening up the CFP basically the same time we throw the site up there and get everything else on there. Um, Also, the first distributed systems meetup is going to be this next week too. I think on Tuesday or Wednesday or something like that. Um, ping me on Twitter at Adrian if you want to go, and I'll get you the details. It's on Meetup, but I forget exactly what I called the thing. So I need to get better at posting. Oh, you know what? That's stupid. Let me just actually pull it up and I'll show you. Meetup. Death cap mushrooms are spreading across America. Way for news to disrupt us. I wonder if I can just do. Oh, hold on. I'm pulling up local, and then I'm going to show you. So yeah, this meetup should be pretty cool. Depending on where you're located at in Portland, it'll be super easy to get to or super difficult. If you're in Vancouver, Washington, it's going to be super, super, super easy to get to. Yeah, interpretive, exactly. That would be seriously rad. Here we go. So this is the meetup next week. Here we go. Oh, look, somebody put a picture up there that wasn't me. That was not me. That's a lot of train right there, but that's not me. So yeah, I'll be heading down Monday on the train from Seattle to Portland to go to this meetup. And also to catch up with some people and get some other planning done around the March meetup and onward into April and all that jazz. Uh, we're going to aim, I'm working with Joe. I don't know if y'all know Joe D. He's one of the head crew over there at, there's Joe D right there. He's been at .NET Fringe, ML for All, I believe Node PDX too. He's heading up architecture at the Home Depot office there in Vancouver. Really cool dude. Um, Definitely say go check it out. Should be a good meetup, and we're aiming to make that at least like a quarterly meetup. We'll see if we can push it up and increase it past that. But right now, it's just going to be kind of a quarterly thing. Our first one here is February 6th. All right. So that's the two big things that I know of going on in Portland. I don't know what's going on in Seattle. There's always the scalability meetup every month, which I organize, and that's pretty good stuff. Uh, Actually, I think if you just type in Seattle scalability, yeah, we always show up because the meetup has been around for so long. It's Bradford, me, Clive, Nick. Oh, phooey, I think I might be missing one person. But yeah, great meetup. Matter of fact, that's where I learned about the event-driven one, which, yeah, okay, February 20. Oh man, I need to put that on the calendar. So yeah, our next meetup is Suze Hinton and Amanda. Then in March, it's going to be Richard Seroter. And then Dr. Ryan Zhang is going to talk about serverless on Abidaba Cloud. So that should be interesting. And there's going to be some more, I'm aiming to get some more speakers on there too. But yeah, so that's what's happening in Seattle. The event-driven one on February 20th, I need to get added to that one ASAP. But let's see here. Close that down here for now. Let's refresh this and get back into maps because maps are rad. Yeah, so hope to see y'all at the Portland meetups. That would be super kick-ass. Um, I'll be asking the audience there too, like what additional things they'd like to see on Twitch streams would be helpful, would be useful, what stuff they can take and download via YouTube and stuff like that, or not download, but watch via YouTube, because everything here gets archived there. And basically trying to figure out what will make it a better programming community set of events that's useful to people and fun. I don't want to do boring shit. Unless, of course, it's self-serving. Like, I do learn how to program programming languages anyway, and I'm sure like 99% of the Twitch community is like, oh, that's boring. I just want to play games. So that's fine. You know, whatever toots everybody's whistle. So here we are, back to maps, right? Uh, just to restate. Let me make sure, is the thing still right? Yeah, okay. So maps are basically a hash table. Hash table is key value, or like in .NET land, that's a dictionary is basically a hash table too. I think a hash table is like the more academic name for it. I don't know. It seems like half the stuff in Microsoft land gets renamed from some other academic thing that already got invented. But I digress. Yeah, so we're doing maps. We're working on maps, and let's make a map, right? We got our clean code base here. Let's say I'm just going to use some of the straight up examples here. Ages is equal to make map string int. Okay, so there we go. We got that. Mapping strings to ints. That's what this is going to do. Now let's say ages is equal to, let's flesh this out more, and let's actually say, whoops, map, Well, let's look at that first before we go to next stage. Let's say format.print line, and then we'll say ages. So this is just an empty map, right? So run that, and boom. So empty map, it just says map brackets, right? Pretty annoyingly straightforward in a way, but what you would expect. So let's nix that and say map and actually give this thing some values and everything. So that int, so same way we just declared it, or same types within it that we just declared, but we're going to give it some values, right? So this is going to be Peterson, and Peterson is going to be 52, and then we're going to have Sally, and she's going to be 22. Is anybody named Sally anymore? I don't even know. Let's say Javovia. That's, sorry if that's a vulgar word in some language. I'm just making up stuff now. It's 15, and then let's say Ben is 42, because we need somebody with the answer to everything. Oh, we need a closing comma, right? Yep. So there's always the kind of the closing comma, even though there isn't another value. I know in some languages, like when you make a list of, or you go through a declaration list like this, you have item, comma, item, comma, item, right? But in Go, you have to have item, comma, item, comma, item, comma, even though there's not a trailing item. The last comma needs to be there. So now let's run that and see what we get. There we go. So map, Peterson to 52, Sally to 22, Javovia to 15, and Ben to 42. Right? Pretty straightforward what's going on there. Let's look at another declaration way, or way to declare this. So let's say, oh, I don't know. Let's job association. We'll say map. We'll do string. Whoops. There we go to string. Oh, we didn't want to do that. I want to do make, boom. There you go. And then just kind of like a, I was going to say like an array, but this is not really like an array at all, the way we do this. Well, I guess it kind of is. So instead of an index, though, you have this map key, right? So we're going to say Peterson, oops, Peterson is going to be mapped to, let's say, engineer, right? Job association. For Sally, it's going to be CEO. And then we'll do one for Javovia. via and that's going to be a gamer. It's a multi-million-dollar gamer. Don't mess with Jovovia. And then bin programmer. There we go. So now let's print that out. Print line job association. Print that out and boom. Same kind of thing. Peterson mapped to engineer, Sally to CEO, Jovovia to gamer, and Ben to programmer. So let's see here. So say we want to figure out, say job association, say Jovovia. We want to find out what Jovovia is doing because we've forgotten that Jovovia is a gamer, right? So run that. And again, just kind of like an array, boom. You're asking for your index or your key in this case, which is Jovovia, and then boom, Jovovia is a gamer. You get that value returned, right? So now let's see what happens when we do this, right? Print line job association Frank. We don't really know who Frank is, but let's run it because there's not going to be a build error, right? What's it going to say? It's just blank. We get a blank. The horror of that, right? So then let's say that does dictate how we would have to handle getting data or not getting data back from this type of data construct, right? So then let's say, all right, print the job association. Let's say ages. Let's say Sally. Oops. There we go. And we'll get 22. And then let's do this. There's this function there. We can just pass in the type, right? So let's do ages. And then we're going to pass in Sally because Sally's mad that we have her age. She wants us to delete that ASAP. So we're like, cool. All right, we'll delete that for you. Our bad. So now when we do print line and somebody says, I want Sally's age, right? Same situation. And boom. 0. So she's 0. Note how that changed. So gamer, let's see what happens when we delete a gamer though, because that zeroes it out if we delete it and it's an int, right? So let's say delete job association and we'll do Jovovia. And then we're going to say format print line. Oops. Job association. And then Jovovia. And what are we going to get? It's going to be an empty string, blank. It's going to break at this point. So blank, right? Now that tells us also, it's not actually, in the case of the int, it's clear that the actual item, which within the map, it's not particularly being removed, the value is just zeroed out, right? Or is it? Is it gone? Let's look and actually say format.println ages, right? It's a job association. So this will give us an idea of what's actually happening. Does it actually remove that element from the map, or is it just zeroing out the value? Kind of seems like it's actually removing the element from the map, which is exactly what it's doing. So in the case where I ask for Sally's age, though, and it gives me 0, because it can't do null nil, something like that with the int, it's saying, well, it's not here, but you get a 0 because you asked for an int. I have to return an int, right? Kind of a little weird in the way I feel about it. I feel like there should be, I don't know if it should break, but it just seems weird that I get a 0 back for that, an empty string for the other thing. But it doesn't mean that there's an element at all, even in the map, right? It seems like you should get like a no element or an empty element. Maybe that's what you're actually getting. And if you tried to then add it, you know, that would get put into the thing, right? Let's see here. What else do we need to talk about in this? Oh, stepping through it. Very cool. Let's do for name, age, range, ages, and then format.print. We're going to do it print F this time. Do S, T, and then a number, int, dash N. Did you get it all right in there? Yeah, okay. So then name, age, and then let's do one for the other thing too, just to see how to do it with the strings. We'll do job, and then, no, actually, let's hear. Name and age. Actually, we'll do name and then job. That's what we'll do. Then range, job. Oh, come back here. There it is. Go, job association, and then format.print F. And then we'll do, let's see here, S, T, S, new line, and then name and job, right? Run that sucker, boom. Pretty nice, right? It's a good way to print out the maps in a way that's nicely readable. So here's our 3 ages. Here's our 3 job associations. Let's actually take this and we'll copy that, and we're going to put it up right after the creation of these bits. So we actually get all 4 of the values from the maps, right? So we'll scroll up a little bit. There we go, all 4. Now, one of the other things, we're in Golang, a little bit of an advanced bit here, but let's say we wanted to clean up this kind of mess of code here, right? Let's say we wanted to make these into functions. So I'm going to actually make this a function. I'm going to highlight it like this, then right click, go to refactor, and I'm going to say extract, extract, and then let's make it a method. Now, boom, there we go. And we'll call it get ages. There we go. So, like, let's say this was a function that actually went out to a database and retrieved stuff, right? So this is a way to break that function out and then have it do additional things and segment that piece of code off into its own little function of activity. And again, I haven't thoroughly covered functions yet. That's going to be in the next session, next Saturday at 10 a.m. But right now, this is an easy way to kind of break stuff out. If you're super new to the language, using Golang, you can get functions and learn a lot just by letting it take you through the steps. Like right here, I'm hitting enter because it's letting me rename each part of that function. So let's go through the same thing, but for job association. So I have get ages here, and that's going to return, oh, look, it doesn't actually return something. So what I need to do, oh, this shouldn't have renamed it get ages. What I should call it is print ages. Let's refactor it again and do a rename. Right? We'll say print ages. Whoa, I goofed it up. Do that one more time. So I'm going to actually do the shortcut key for me, which is Shift F6. And it says that, but I want to do print ages and then hit enter. And as long as it's got the little red line around it, that means it's still in edit mode. So print ages, and boom, there it is. It renamed it here and here, all of its dependencies. Golang is super awesome with its rename capability. If it gets super complicated, it gives you a whole printout at the bottom about like, here's all the things that are going to be renamed. Does this look okay to you before you do it? So very, very nice IDE functionality. So let's go to the next one here. We're going to do print ages again and take a little bit closer look at it. So again, I'm going to right click so you can see what I'm selecting. And I'm going to say extract and then method, which is Control M for me. It's different on however you install Golang and stuff. Right, you can tab, but you don't always want to tab. Like here, okay, so we're in the first one. I want to rename the field, right? So I'm going to say print, print jobs, right? Then I'm going to hit enter, and it's going to put me over to job association. Do I still want to have this name this? Or let's say go with job association. Yeah, there we go. So I renamed it in the function. And then that is the type I want. So go ahead and hit enter. And then, oh, it didn't do this. There we go. Okay, I fixed it anyway manually. But you get the idea. It gives you the ability to rename throughout the function and name your function when you do the move it out to whatever. So it's one of those features that I freaking love it. It's awesome. So let's do a refactor again. Rename, and same thing, right? So let's select all of it and then print job associations. Enter. So renamed it there, and it knows there's a function. So I can go both ways with that. I can rename it here, or I can rename it at the function, wherever I'm at. Makes it easy so that wherever you're at in code, you just rename it, and then boom, you got the more logically named thing. So now let's see your ages, job association. So this is, let's see here, declaration of stuff. Yeah, we just leave that there. And let's see here. Does it have? Of course, it doesn't have that. I'm trying to think of other little pieces of this that I can cover because maps are super elaborate. There's a lot of other stuff to look at in this regard. And at the same time, I can't go through every single little nitpicky detail that's in the book because there's a lot of material in the book around this. Trying to get the bases covered just enough to really know it well enough that you can thoroughly write some Go and know what you want to research past whatever we've covered. So with that, I think we've covered a fair key amount of stuff in these. I'm just gonna have them compared to each other. Legal compare. That's one thing. As with slices, maps cannot be compared to each other. The only legal comparison is with nil. So to test whether two maps contain the same keys and the same associated values, we must write a loop. Let's actually do that because that's a key thing to be able to do, right? Let's say, yeah, X map. Yeah. So first, let's get we're gonna write a function here. I feel like I should do this in the function thing, but we're gonna write the function. So func equal and x, y, and each of those are going to be a map of string to int, right? Close that. We're going to return a bool of whether it's a match or not. Yes, no, true, false. And let's see, if length of x is not equal length of y, always fat finger that and hit a bracket. That's weird. So return false. So kind of not a complex equal. Like it doesn't really tell you what the heck's going on and why it's not equal. But it will, if the length isn't the same, boom, so it's not equal. So you're gonna get a false back. But then let's do the comparison, right? For k x, oops, v equals range of x. So xv is x value, k is key, k key, k is key. That's kind of weird now that I think about it, language-wise. So if y value, okay, equals y of the key, and then not okay, or yv is not equal to xv, bracket. Is that right? Did I type that right? No, I got something backwards. Here we go. Okay, fixed that. And oh, why did, I guess it printed out key and then did something. YV is okay is equal to da da da. Not okay is equal to da da da. Okay. So return false. And if all that's lovely, we want to return true, right? Unreachable code. Is it? Why is it unreachable code? Shouldn't be unreachable code. So equals if length x is not equal to length y, return false. Okay, that's true. Oh, I don't need a comma here. Oh, there we go. Okay, so it was just messed up. Cool. So now let's go up here. So we have one map that's map string int, right? This one. So let's create another map of ages, and let's say it's just a different team of Frank, Johnson, Smith, and Jezebel. And let's say let's say the values are the same, right? Strings, not the same. Values are the same though. And then let's do this, ages. We're gonna have 3, whoops, 3, and then 2. There we go. And now let's do some equals, right? If, oops, equal ages 2, format.print line, nah, not really equal. Else format.print line. There we go. This is correct, not equal. Right? If equal, then we'll say, let's say ages 2, ages 3, and this should be equal, right? Because I literally did a copy and paste. Format.print line true. These are effectively the same map values and keys. Now note, of course, we only did the, let's see, okay. Yeah, we'll see. What did we get? This is correct. First set is not equal, and we did get the next one, which is true. These are effectively the same map values and keys. So that is the result we expected. So very, very good. It's always good to get the result we expected. All right, now on to the next fun composite type here. We're getting close to the mother load one, JSON. So let's get this committed. This is the commit dialog for Golang, which if you've seen the last sessions, it's become familiar at this point. Examples of map types. Here we go. Commit and push. Checks it out. It's going from origin to learning maps. That is where we want it to go. Push. Then we're going to bounce back into terminal. And I'm going to look at, okay, just wanted to check real quick. All right, clear. That down. List. Oops, clear. List. It looks like we're all good to go there. So then let's do get checkout, new branch, and we'll call it structs example. There we go. And again, go back through. Let's wipe out our little functions there. Get rid of all that code, cleaned it up. There we go. Now, a struct is, what is a struct? Almost seems like an existential question. But yeah, so a struct is an aggregate data type that groups together 0 or more named values of arbitrary types as a single entity. Okay, so basically, let's see, each value in that entity, it's called a field. An example of a struct from data processing is like the employee record, right? Where it has a unique ID and the other associated values along with that unique ID, like the employee's name, address, date of birth, position, salary, manager, and all that. So kind of like a map in some sense, but it goes far past just a key value of that map. And it goes into the realm of adding all the peripheral data around something that you need. And one can definitely think of it as kind of like an object, right? I loosely use the term object in Go since it's not an object-oriented language, but it does have things commonly referred to as objects, and this is one of them. So let's make a struct. Let's see what that puppy looks like. Again, start off with type. We'll say employee. Just use the example in the book there. Do ID, int. Actually, let's hear. What do we? We'll go with string, actually. So we don't want to do that. Yeah, I'm going to leave it with string for right now. Then we'll do name, string, address. Oops. And notice there's no, I'm not using a comma here for this. So it doesn't need commas. It just needs the element, okay, and then the type of the element within the struct. That's all you need for this, because basically once you put the type, it knows that that is the particular field or element of the struct, and it's open to the next one in the declaration now. So then date of birth, which will be time.time. So introducing that type, which is kind of a complex type. Then position. It's just like int and string, stuff like that, except it's a complex type in the sense that there's multiple ints to the value, etc. Position, string. Actually, I'm going to say job. There we go. And then salary, int, or should we do float? And what happens if I just do, I guess it's going to want one of the two. And then manager ID, which would also be a string because it would map back to someone else's ID, right? Now note in Go, if I put ID like this, is it going to fuss? No, it's not. Weird. Okay. The convention is generally if you have an abbreviation or an acronym, it's all uppercase. You don't do like partial lowercase or whatever. And the linter in GoLand will catch that and give you a little squiggly line most of the time. Just like here, I haven't used this, so it's giving me a squiggly line and graying it out, showing it's not used currently. So now, let's say, we're just going to keep going with this example. We have var Dilbert employee. Okay, so we've just declared a new variable called Dilbert of type employee, right? So then, if we want to say Dilbert, let's set his salary to something. Let's set, oops, there we go. Equals 5602.66. Okay. Then we're going to give him Dilbert a name, right? Dilbert needs a name. Dilbert Max Million. Millarn. That's fine, whatever. And then we got Dilbert dot job. We'll say engineer complainer. Oops. Or genius. Call him a genius. Something nice, right? And then Dilbert dot address equals that place in the cartoon. Boom. Okay. So we have that now. Let's see if we can print some of this out, right? So print line. Let's see what happens when we just type out Dilbert, right? And let's try print line Dilbert dot salary. And let's try printing out his name. There we go. All right. So when it prints out the overall struct, you see the values. You don't particularly see the field keys, right? Or the field, the field names, right, themselves, the property names. So like on salary here, you just see it's just the value is printed out. The key there really is the property name on the struct, so salary. Let's see here. Another thing, let's see what else we can do here. Some of the examples in the book is hilarious. Again, just to reference the book real quick, that I'm kind of going through as a guideline to make sure I'm hitting on topics and giving good examples and stuff, is this book by Donovan and Kernighan. Awesome book. Go get it if you want to dive in even further into the specific pedantic details of Go. we're getting into a lot of the material and doing a lot of additional material outside of that based on having an IDE and other things and actually looking at the ecosystem around it. That's way more expansive than just the book, but if you want to get into specific pedantic details of the language itself, definitely get the book and read every single line of it because it's a great book. All right, so that's kind of the 101 on structs. Let's see here. Trying to look. Oh, here's an interesting thing. Should we do that? What is our time? 11:59. I'm going to actually bump us into JSON land because we need to get into JSON land. And the time is short before I step into later, around about an hour and a half from now, I plan to step into killing off Windows 10 and putting Linux on this machine that I'm actually streaming from. And I'm going to actually stream that entire process using my other machines to show you the installation process of getting Linux up and running on a machine and really how blindingly bloody simple it is. It's freaking awesome. So join me at 1:30 p.m. to check that out. But for now, we're going to commit that, call structs a day, and move into 101 on JSON. And then I'll most likely continue on the JSON and the pedantic details of JSON because that's very important next Saturday at 10 a.m. also. But for now, let's see here, this is example of structs. There we go. I'm going to push that to origin to structs example. Oh, you can change it right there. I did not even know that. I just learned how to do that. So another feature of Golang, when you're doing a commit, when you get into this commit dialog, you can change this right here. And I'm curious, let's say struct, let's say creation struct, actually, let's just say struct example. So that doesn't actually exist. Struct example new. It doesn't exist in the remote repo, and that's why it's saying new. So we'll see if this actually creates this one for us. So yeah, let's do a force push. You're going to force push struct example. It may overwrite commits in the remote. Yeah, don't worry about this. Target force push. And here, see what we got so far. We got struct example and learning maps. Oh, it already got it in there. Cool. So there we go. And there's our example. Looks good. Cool. All right. Back to this. Now we're going to do another one. I wonder if there's, let's look in here and see what options we have for commit, update, local, git, branch. Is there a branch option? Rebase. I don't want to rebase. Rebase my GitHub for it. Create pull request. View pull request. Oh, that's interesting. We'll look at that later. See, this material in these sessions, totally not covered in the book. And this is the kind of stuff you need to know to be able to work on teams with version control, especially Git, Go, and all that kind of jazz. So we're covering a lot of good uses to make you better, faster, quicker with the tooling. Yeah, I don't see how to do a branch here. Commit, update project. I know I didn't need to force push, but that was the button option. I don't actually know why it told me to do that. But then of course, oh, here's branches. Let's see what this does. New branch. Just trying to, mix the IDE in with everything. Here's our remote branches. This is pretty nice looking actually. Oh, so this is master, but then I don't know what put the favorite tag on there would be. That's kind of weird. Check out tag, or let's do new branch. That's what we're trying to do anyway. So new branch. And we're going to look at JSON examples. Boom. Branch JSON examples was created. So that means, so I guess we should be on it then. So yeah, it's basically doing git checkout dash b, whoops, JSON examples. That's what we just did, but we did it via the interface. Oh, is that what it is? Okay, that's interesting. Adam just pointed out that the star in that interface thing here, git branches, if we change the star, that would change where the head of the repo is, or the branch, right? Branch, how would you say that? We change the where the head of the Git repo looks. Yeah. So anyway, we don't need to do that though. Getting into some complex stuff there. I feel like maybe I should do a whole session on Git and have you join me and do like 80% of it because you are the Git person. I just make it do everything I need it to do, and it does it beautifully. So I love it. Okay. So yeah, we're on JSON examples. We don't need to execute this. Yeah, I love it. I love how it's done that. That's super rad. So like if I get status, just confirm JSON examples. So we're gonna go ahead and nix. Do we want to nix? We're not gonna nix all that. We're gonna actually turn this struct into a JSON prepared struct. That's what we're gonna do. So let's go in here. This right now is actually in a state that is usable to basically export the JSON. But let's look at that real quick before we start to tweak on it too much here. So let's say data is equal to JSON dot Marshall indent. No, just Marshall. Yeah. Then we're gonna add Robert. And do we need to add anything else? I think that's all we need to add. Yeah. So then let's do format dot println data. And yes, we should need to deal with error, and we'll do that just to get the practice. If error is not equal to nil, format print and print out error like that. Oh yeah, Adam, when is your next session? Oh, that's the binary. You see it right here, the binary of the data. So we actually need to marshal it first. Or do we? Oh, if it's, yeah, doing it backwards. So marshaling takes the JSON and it'll print it out. So let's turn this object into a JSON object, right? So this is a normal struct. We just created it a few minutes ago. We got name, address, date of birth, etc. But let's make sure that it has specific JSON attributes, etc. on it. And the way you do that is you do a backtick, okay, and say JSON, and let's call it name, right? And I'm going to actually go through and kind of do it the JSON-y way for each one of these. This, and we'll do manager ID, salary. Actually, let's do ID like that. We'll do job, date of birth, address, name. We'll do ID. Actually, let's do, just so you know, it's not doing any crazy casing stuff, of birth. So there we go. We've got different types of casing. And then let's save it. And then also let's go and run. So go format. Oh wow, that's pretty trippy. It just got stuck on that. That's it? Come on. Oh, derp, go format. There we go. So it did main.go, and there we go. It lined it up pretty for us. So that's good. Let's run it one more time. I think it's gonna, yeah, no. Okay, it did everything. All right, so we actually have a struct now that is a JSON object, right? And then we have some of the values assigned here, as you can see. But let's really get into it appropriately here. So let's say var Dilbert equals, and we'll say, what's our thing? Yeah, employee. Okay. And now we're going to actually assign it the JSON appropriately. So here we'll do ID. You saw the IntelliSense start to pop up, and let's get a GUID. Or did I make it? I did make it a string, right? Yeah, I made it a string under the premise that it would be a UUID or a GUID. I deal with big data all the time, and yeah, you don't want an ID as an int. You just don't. There's no real reason to use that these days. So there's a nice UUID, and then let's go with name. Yeah, so there's name. Let's say Dilbert max million. And then we can go new line here if we want to. Whoops. So we have one on each line. I like it to kind of read. Oh, and remember the commas for go. Needs one at each one. So we're just going to name, let's see, we'll do that, and then I have a salary of 52, 520 grand, 405,000, and 50 cents. And then we're going to create another one, again, those commas. ID, let's get a new one, refresh that page, boom, boom, copied. I think I just messed up the window sizing there, did I? Just fixing a thing real quick. Hold on. There we go. Okay. Da, da, da. So we got the ID. We don't want all those extra spaces. Oh, and this type here. This is actually a float, so I should give it a float in Go syntax, not JSON syntax. So this is where things can get mixed up, right? Because I'm writing a pseudo JSON looking format here, and but it's not really 100% JSON. It's not really 100% Go. It's kind of like a hybrid in between on its way to being marshaled into JSON. So here, name. Let's call it. This record will be Sally Jackson, and salary for her will be 690,000 and 50 and 32 cents, right? Yeah, definitely should make more than Dilbert because Dilbert's a jerk. No, actually, he's a nice engineer. He's a perfectly nice engineer. Job, let's say, product architect. There we go. And then that's good for now. Just leave the other ones empty. Okay, so we got that. Now, let's get rid of these bits. Actually, let's leave those. Let's look at what that prints out right now. What does that give us? Ah, broken elements, right? Has no field or method salary. Oh, that's because I've turned it into an array because it's multiple people. Let's go with 0 and 1 because we know we have 2 in there. 0-based index would be the starting point. There we go. Value and value initializers. Mixtures of field value and value initializers. Crazy talk. At 2819. Oh, comma. I don't need a comma there. There we go. That was a quick fix. So there we go. We have that printing out. So the first bit prints out the whole deal here like a struct. Because remember, this is stored as a struct still, even though it's JSON, and we're going to marshal it into actual JSON in a second. So there's the salary, and then there's the name. So now with that clearly laid out, let's actually data JSON.marshal, and we'll do Dilbert. I don't know why I've named that Dilbert. Let's actually just call it employees, right? Refactor, rename again, employees. Boom. There we go. We got our employees now. They're marshaled. We'll say if error is not equal to nil. Come on, get into brackets. There we go. We'll say format dot print line is error. If there is no error, then we want to print. Let's do print f. We'll do string, new line, and then we're going to print out that data. So what's that going to give us? I'll tell you what it gives us. Boom. First printout of actual JSON. So you see open bracket, just like you would in JSON when you're about to see an array, and the beginning of the array elements of the JSON, done with the appropriate naming that we gave it up here. Oh, I've lost my mouse. Okay, so Adam, when is your session going to be on all that? Oh, this is super weird. Why have I lost my mouse? Boom, boom, do do do. Oh, I think I know what might be the case. No, I've literally lost my mouse completely. But with that, you see what we've covered here. We've covered every single one of these elements. I'm going to open this back up again. Maybe. Actually, let's see if I can just do this without any mouse pointer. It's going to open that back up. Oh, looks like I have my mouse back anyway. But, all right. So each of these JSON names over here, these attributes here, have basically overridden in the JSON file the actual struct name. But if you scroll down and look how we refer to it, if we want to refer to the items in the struct, right, in code, we still just go this route, where we say print line employees. We'll look at the second employee, and let's get Sally's name. There we go. And then, so when we run that, we'll get Sally's name and then all of the JSON. Yep, so there's Sally, and then there's all the JSON. Right? Cool beans. So with that, let's actually close out of this. Oh, weird, my screen's messed up again. There we go. Okay, I'm gonna close Golang. And here's all the things we covered today. Arrays, slices, we looked at append, we looked at some in-place slicing, where we like pick parts of the slice. We didn't do that very thoroughly, so I'm actually gonna take it out so that I remember to look at it a little later. We looked at maps, structs, we skipped struct literals so we could get into JSON. We covered all these pieces. That's pretty good. I think we could have done a little bit more, but I got into some of the weeds on some of those things. But we do need, if we're going to write Go, we do need to know the details around that. And eventually, writing Go, you're going to run into all the details there. So let's put this, save it, close it. There it is on the desktop. Clear. That's going to be the basis for the blog entry that I'll do soon on this episode. I'm kind of behind on those. I just have the first blog entry posted, and I'll have the second, third, and fourth, hopefully this coming week. As I'm down in Portland, I intend to blog those since I'm not really going to be Twitch streaming too much while I'm down there. But let's see here. I'm going to go into my Go directory, and we'll get that committed. And oops, learning episode 4, get status. Looking at that, we have our main file to commit. JSON step 1. All right. Now look at the status on that, and let's do get push origin JSON examples, and that'll push our branch up there to the repo. GitHub, and we'll just go look at it real quick. Make sure everything is where we expect it to be. And there's all the branches. There's JSON examples. Go look at that. There we go. Looks good, right? Cool. So now the question is, in the interim, who should we go raid? Any thoughts on that? Anybody got raid notions? Looks like who should we raid? Who should we raid? Let's raid dev chatter for now. Remember, I am tearing up the Linux box a little later. So that'll be super rad. So join me at 1:30 p.m. for that. I'll post a tweet just to have the bookmark out there. But for now, let's raid dev chatter. Got 4 of you. Anybody else? Is that it? All right, here we go. Raiding dev chatter now.